What you just saw was a thermite reaction. Thermite is a redox reaction between iron oxide and aluminum metal. When heat and catalysts are added, the reaction produces iron metal and aluminum oxide. A catalyst is a substance which reduces the activation energy of a reaction, causing it to proceed more quickly. Possible catalysts are magnesium strips or potassium permanganate, and glycerin, which is used in this experiment. In this experiment, heat is given off as well as light. When the heat energy is added to the metals, the electrons in the outermost energy levels become excited and go to higher energy levels. As they return to their ground state energy levels, they give off colors, and that's why you see the red aura. A redox reaction is a reaction in which two species lose electrons and gain electrons respectively. One is called the oxidizing agent, and the other is called the reducing agent. These reactions tend to be very powerful and, as shown in the thermite reaction, give off lots of heat. In this reaction, the balanced equation is shown on the screen.
Now, notice that little blue spark that's happening on this little burner. Now what that spark is a spark created by the electricity of the house. And what that serves to do is ignite the gas by increasing the temperature of the surrounding air. Now, when that temperature is increased, the reaction of the natural gas and the oxygen in the air is catalyzed. It reaches its activation energy. And then, after that, the reaction is sustainable without the spark. Okay, when I turned on that grill, you saw, or you heard rather, a thump. That was the result of the natural gas being combusted. The products of the combustion reaction with the natural gas is carbon dioxide and water. When the grill was first turned on, there was a buildup of the natural gas, so there was an increase in the partial pressure. When all of that gas was ignited at once, it released all of the products, the water and CO2, very quickly, causing it to fill up the volume in the air and push all the surrounding air away, causing the whoosh sound that you heard.
When this grill is turned on, you see a spark of electricity. While that's sparking, natural gas is pouring out into the stove, increasing partial pressure and filling the volume with natural gas. Once the natural gas hits that sparker, the spark will create one little tiny bit of heat in one spot, and it'll cause the entire ring of natural gas to catch fire, which is what happens when you see a stove light up. And then when you put the pot on top of that, there's conduction, where the heat transfers from the flame to the pot. And then the pot will do the same thing, transferring the heat from itself to the food or liquid inside the pot. Now this works because as soon as the liquid is in the pot, the heat will go to it. But that will start boiling at a lower temperature. The pot is made of metal, and so it has strong bonds and won't melt for a long time compared to the food, and so it can be used as a vessel for transferring heat from a fire to the food.
So here we see, in this instance of cooking, we are taking the exothermic reaction of burning gas, and we're using the energy created by that to melt the solid ice found in this bread. Once that ice is melted, it will begin to vaporize, and we'll be left with dry toast. And now you can see in this toast that once the water has vaporized and boiled off, now the bread is undergoing a process called pyrolysis, in which the organic molecules in the bread are broken down, causing the formation of char. And that's what toast is. Heat is transferred to the cheese. You can see that the London dispersion forces in the cheese can't hold it together anymore, and so it starts to melt and become a liquid.
There are two main things happening with the bread in this demonstration. The first is that, as you can see in the drawing, there's the bread in the pan with some fire underneath it. The bread has been previously frozen, so that means that there's ice in the bread. When the heat is added, the ice will eventually reach its heat of fusion, and the ice will melt into liquid water. And then it will later meet its heat of vaporization, and then that liquid water will turn into gas, which is given off as water vapor, which you see as steam. And then the second thing that happens is a process called pyrolysis. Now the bread is made up of organic molecules, and when the heat is added, it turns all the organic molecules that the bread is made up of into H2O and CO2 as a result of combustion, as well as tar and charcoal, which is the black part that you see on the bread.
Now, this is kind of a non sequitur, but right here what we're doing is we're just heating up some tea in this little pot. And the reason we're able to do that is because the metal that this pot is made out of melts at a very, very high temperature, and therefore it's able to withstand the heat of the burner. On the other hand, the tea in the pot is almost beginning to boil right now. That's because of the bonds in the tea being far weaker than the bonds in this metal. Alright, now in a demonstration of the action of solution, here we have 3 separate cups of iced tea. These 2 are chilled while this one is heated. Now if you look in the bottom, we have put in 3 spoonfuls of honey, 1 into each cup. Now I'm going to stir this one and leave this one alone, and we're going to see how the heat affects this one. You can just end there. Now we see that after a minute has passed, the honey in the normal, unstirred glass has hardly dissolved at all. The honey in the stirred glass has dissolved considerably more than the normal glass, while the honey in the heated glass has almost completely dissolved. Now, what this demonstrates is that the presence of heat in a liquid causes the molecules to move around more, which in turn creates a higher rate of collisions between the water molecules and the sugars, allowing the sugars to dissolve more quickly. In a similar fashion, the stirred cup also increases the motion of the molecules, allowing those molecules to dissolve more quickly. For legal reasons, is my mom pouring alcohol into water.
As you can clearly see, the alcohol is mixed with the water. This is because the alcohol is miscible, which means that it is a liquid soluble in another liquid. In this demonstration, you saw the miscibility of alcohol and water, which basically means that 2 substances can be mixed in any proportion to produce a homogeneous solution. Alcohol is a substance which is produced through fermentation. Basically, it's when you take a sugar, so potatoes, wheat, starch, something like that, and react it with yeast in anaerobic fermentation, which means without oxygen. The results of this reaction are ethyl alcohol, which is the drink, and carbon dioxide. Fermentation is also used in the human body when you don't have enough oxygen, and so you need to produce energy, but you produce lactic acid as opposed to ethyl alcohol.
So on a side note, if you've ever had this happen to you while pouring water out, then what you're witnessing is the results of the adhesive and cohesive properties of water. Now see, the adhesion of the water causes it to stick to the side of the glass, while the cohesion of the water causes it to stick together into a stream. And that's what causes that really annoying shit